Hello, folks, and welcome again to another edition of Physics Online, where today we'll talk about vector addition. But first, what I would like you to do is to take a look at these review questions right here. So get out a pencil and also get out a calculator because we'll be needing it in terms of using some trigonometry. Make sure your calculator is in the degree mode. So push that pause button and see if you can answer these review questions. All right, let's check some answers. Scalar quantity has magnitude only. Vector quantity has both magnitude and direction. Which of the following are vectors and which are scalars? Well, velocity is a vector. There's v for velocity and v for vector. That's one way to remember that. I misspelled this here, but you can correct that. Distance is a scalar. Speed is also a scalar. S for speed, S for scalar. Mass is a scalar. There's no direction associated with mass. And displacement is also a vector quantity. It has both magnitude and direction. So now let's take a look at vector addition. And we'll do it by looking at this particular example. Vector analysis can be used to help pilots navigate their plane through wind and storms. Imagine a plane has an airspeed of v sub p, 300 meters per second. The p obviously stands for the plane. Now suppose there's a constant tailwind. This is a wind that's blowing from the back of the plane to the head of the plane. That is, it's blowing from the tail, and it has a velocity of 20 meters per second. That's the velocity of this wind. And as you might guess, it would make the plane go faster. In fact, what's the resultant velocity of the plane relative to the ground? As you might guess, it's 320 meters per second. But we want to find the answer by adding two vectors geometrically and then finding the resultant. To do this, there are two very important steps for adding vectors geometrically. The first step is that we add vectors by connecting the tail of one vector to the head of another. The vector sum, or resultant, is found by connecting the tail of the first vector to the head of the last vector. And I'm going to use this example right here and show you what we mean by this process of adding vectors. Okay, we're going to start with a vector equation. V sub r is my resultant, and it's a vector sum. V sub p is the velocity of the plane, and v sub w is the velocity of the wind. And if we apply this first step right here, we're going to add vectors by connecting the tail of one vector to the head of another. And this is what I've done right here. This is the velocity of the plane, and I simply have connected the velocity vector for the wind, that tail, to the head of the velocity of the plane. And so we have added these two vectors geometrically. Now, to get the resultant, the vector sum or resultant vector is found by connecting the tail of the first vector to the head of the last vector. And that's what I've tried to show right here. I've moved it down a little bit so you can see it. But here's the tail of my first vector, v sub p, and I've connected that all the way to the head of my final vector, v sub w. So this now is my resultant. And of course, that resultant in this case would simply be the algebraic sum, that is 300 plus 20, or 320 meters per second. Okay, let's continue. Okay, make sure you write this geometric vector addition expression in your supplement, and then we're going to take a look at this example number 2. Suppose we walk 3 meters north and then 4 meters east. What is our resultant displacement? We first represent the displacement vectors as x sub 1, that's our first vector, and it's equal to, of course, 3.0 meters, and we're going north. The second vector can be represented by x sub 2, and we're going 4.0 meters east. The resultant displacement vector r is the vector sum. So here again we have a vector equation. And so we're going to have to apply the rules above for adding vectors. Note that this vector equation does not imply that we find the algebraic sum. In other words, 3 meters plus 4 meters equals 70. That is not the answer, okay? Because these two vectors lie in different directions. One is north and one is east. So it's not like the previous example. this vector equation here is an equation, so we must follow the steps, the two-step process for vector addition, in which we must consider the direction of x1 and x2. So let's take a look at this in terms of the coordinate axis, and that's going to be our reference system right here. And first I want to see if you can come up with a solution. And here's the direction stated very explicitly so that you can follow the course of action here. Starting at the origin, right here, we're going to draw the displacement vector x sub 1 equals 3 meters north. And then we're going to connect the displacement vector, the second one, x sub 2, 4 meters east, connecting tail to head, the first step. This is the first step of our rules for adding vectors. To get the resultant, then you will take this displacement vector r by drawing the vector which is the shortest distance between our starting point and our end point, and use the Pythagorean theorem to find the magnitude of this vector sum. And notice there's absolute value signs around this quantity right here, and that indicates the magnitude. And then to get the direction of the vector sum r, we have to use some trigonometry. So get started on that, push that pause button, and then we'll take a look at what we come up with. Okay, let's check our answers. First of all, the first vector x sub 1 started at the origin and it moves north by a distance of 3 meters. The second vector, you connect the tail to the head, and that's x sub 2. Move this down a little bit so you can see it. Here's x sub 2. We're connecting the tail of this to the head of my first vector. Then to get the resultant, we go back to the tail of the first vector, x sub 1, and we connect that to the tail of my final vector, x sub 2. This is my resultant. And basically, it's the shortest distance between our starting point. Here's where we started, and here's where we ended up. So it's the shortest distance between our starting point and our end point. And to get the magnitude, then this is a right triangle here. You can see that it's either a 3, 4, 5 triangle, or if you need to, you can use the Pythagorean theorem to find that this resultant right here is equal to 5 meters. To get the direction of the vector, we're going to use the inverse tangent. We're talking about this angle right in here, opposite over the adjacent. That gives me 53 degrees east of north. Okay? It's east of north basically because we're talking about going to north this way. That's our first vector. But to get on our resultant, we have to go toward the east to get on our vector right in here. So this is how we get that particular angle. We could also have used this angle right in here, which is the complement, 37 degrees. And so that would be north of east. In other words, if we went due east this way, we'd have to go toward the north this way, toward the north, to get on our vector right here. So either one of these is perfectly fine. In fact, some textbooks simply write the direction as 37 degrees above the horizontal. Here's the horizontal, 37 degrees above the horizontal. Now, our final answer, therefore, becomes the resultant is the vector sum of x1 and x2. It has a magnitude of 5 meters, and the direction is 53 degrees east of north. And again, note that the displacement is the shortest distance between the initial position and the final position, whereas the total distance is a scalar quantity whose value is, well, push that pause button and fill in this blank right in here. What is the total scalar distance? So let's check our answer. The total scalar distance was 3 meters, and then added to 4 meters give me 7 meters. In other words, if we take a look at our vector diagram, we can see that we travel 3 meters north and then 4 meters in this direction, and so the total distance traveled is 7 meters. A very different answer compared to the resultant, which was the shortest distance between the starting and end point, and that was only 5 meters. Let's continue. Take a look at this other example here. I want to use vector addition to find the resultant displacement vector r equals x1 plus x2 plus x3 plus x4. These are our vectors. x1 is the first vector. It's going 4 meters north. x2 is going 4 meters east. x3, 4 meters south. And x4, 4 meters west. So you're going to start at the origin here. I just want you to draw the vectors themselves, add them up using the rules for adding vectors, and then write in the displacement vector, write in the total distance traveled, and then see if you can answer this question. Notice I've changed the order in which we add these vectors. Okay, what result do you get even when I change the orders? So push that pause button and let's come back a little bit later and check our answers. Okay, let's check some answers. First of all, let's add these vectors up geometrically. We started with x1, it starts at the origin, it goes 4 meters north. Then we connect tail to head, x sub 2 therefore goes 4 meters east. X sub 3 connecting tail to head, but it now goes 4 meters south. And finally, x sub 4 goes 4 meters west. And so we end up right back where we started. That is why the resultant displacement is equal to 0. The difference between our initial position and our final position is 0. On the other hand, if we ignore direction and look at the total distance, the scalar quantity traveled, then we come up with 4 plus 4 plus 4 plus 4 equals 16 meters. Note that we could add these vectors in any order that we please. That is, we will always get the same result. Now, as more practice, I want you to take a look at this problem right here and push that pause button. I've given you the answer so you can check. So use your scale here, your reference system, and label the vectors clearly. Label your angle clearly, and show all the work, and do so in your supplement. And when you have completed that, then we will have completed this exercise on adding vectors. So thank you for tuning in, and I hope you learned some physics.